Today, I brought this jet blower here for testing, but there's a problem. No matter how many times I press the switch, the machine still doesn't work at all. I remove the battery and reinstall it to test one more time, but the result is still the same. It seems the problem might be with the battery. I press the power button on the battery, but none of the battery indicator lights turn on. This shows that the battery may be completely drained or have an internal issue. Now, I'm going to use the original charger to see if this battery can still be brought back to life. But when I connect the battery to the charger, the indicator light does not change color like it normally should. This means the charging process is not working. To make sure, I use a light bulb to test the charger again. When I connect the light bulb wires to the charger, the bulb lights up normally. This proves that the charger is still supplying power properly, so the problem is not with the charger. Next, I attach 2 washers to the battery contact slots to create temporary test points. Then, I connect the light bulb wires to these 2 washers. But this time, the bulb does not light up at all. This shows that the battery may have an internal problem and can no longer provide power. It looks like the issue is more serious than I expected, but I already have an idea to try fixing it. First, I place a piece of tape on the battery and mark it with an X to identify the inspection area. Next, I will remove the outer casing of the battery to see what is happening inside. After taking a closer look inside the battery, I noticed that there's quite a lot of dust built up inside. This dust can affect the electrical contact and reduce the battery's performance. Next, I use a paper towel to clean around the battery casing and the internal components. This first cleaning step helps remove the larger layers of dirt before deeper cleaning. In the next step, I use WD-40 to clean the circuit board and the internal components inside the battery. This solution helps remove dirt, clean light oxidation, and improve electrical contact between the components. After that, I use a piece of sandpaper to clean the inside surface of the contact slots. This step helps remove residue and improves electrical contact. Then, I dip a cotton swab into the liquid and begin cleaning each detail on the circuit board. Using a cotton swab allows me to clean more accurately in small and hard-to-reach areas. In the next step, I reuse the inner core of a motorcycle valve as the connection part for the wiring system. First, I use tweezers to remove the inner valve core. This small metal part has good conductivity, making it suitable as a contact connector. Here, I have two small wires, and I will use them as the temporary power transfer system for this battery. First, I strip the wire ends to expose the copper cores inside. Then, I twist the copper strands into two smaller branches to make the connection stronger and easier. Next, I twist the wire ends firmly onto the motorcycle valve core. This part will act as the main contact point when connected to the battery slot. Here, I also have two metal rivets and another motorcycle valve core. I use these parts to create the connection terminals for the other ends of the wires. First, I connect the remaining wire end to the metal rivet. Then, I repeat the same process with the red wire to complete the second connection wire. At this point, the temporary power wiring system is complete and ready for the battery connection. Here, I have another battery of the same type, and this battery is fully charged. I will use it as a temporary power source to transfer energy to the drain battery. Next, I connect the wire ends to the contact slots of both batteries. This creates a direct power path between the charged battery and the drain one. This process allows some energy to transfer from the charged battery into the weak battery. The purpose of this step is to raise the voltage of the drain battery to the minimum level required for the original charger to recognize it again. In simple terms, this works like a jump start for the battery. After about 15 minutes, I disconnect the two batteries. Now, I reassemble the battery casing. Once that is done, I use the original charger again to continue charging the battery. This time, when I connect it to the charger, the indicator light turns red. This means the charger can now recognize the battery, and the charging process is working normally. After about 20 minutes, the battery is fully charged. When I press the power button, all 4 battery bars light up. To make sure it can deliver power properly, I use a light bulb for testing. When I connect the bulb wires to the battery, the bulb lights up normally. This proves that the battery can supply stable power again. Now I attach the battery back to the jet blower and test it. And as you can see, the jet blower is now working normally again. Finally, I take it outside for a real-world test. This experiment shows that sometimes a battery that seems completely dead can still be brought back to life if handled the right way. This not only saves a significant amount of money on repairs or buying a new battery, but also helps reuse old equipment instead of throwing it away. If you found this video useful, don't forget to like and subscribe for more repair tips and interesting DIY ideas. Thank you for watching, and I'll see you in the next video.